You're welcome. In this video, we're going to look at solving equations that involve multiplication. Now, the first thing we need to understand is just because you see there are a lot of videos or a lot of lessons about solving different types of equations, and you might be confused about, oh, how do I solve an equation in this type, in this type, in this type? What if we're solving for y? What if we're solving for x? Now, what we need to understand is the whole goal of solving an equation is the same thing. Okay, whether we're solving for x, whether we're solving for y, whether we have one variable in an equation, whether we have two or three, the whole goal of solving an equation is the same. Okay, our end result is we want to get whatever variable we're solving for all by itself. Now, sometimes that variable might equal a number. We might get like x equals 2, okay, or a equals -3. Or sometimes it might be an expression, like we might get y equals 2x plus 4. Okay, m equals -2n minus 5. But our whole goal, no matter what, whether we have one variable or two or even three, if we're solving an equation, we just want to get whatever variable we're solving for all by itself. Now, when we have equations with only one variable, we're trying to find the number, the only number, or sometimes there might be more, but the number that makes the left expression equal the right expression. So no matter what, if we're solving an equation with only one variable, okay, whether it's a proportion equation, whether it's just a regular equation, or whether it's one of these types of equations we're going to look at now, the goal is to figure out what number is going to make the left expression equal the right expression. So let's start with this example. So we have 3 times the quantity 2x plus 7 equals 15. Okay, now there's nothing new in this equation. Okay, we might not have ever seen an equation like this before, but we've seen equations before, and we've seen something that looks like this before. We know how to distribute. So there's really nothing new in this equation. We just want to kind of put all of our previous knowledge together so when we see an equation like this, we're comfortable working through it. Okay, so we want to solve, okay, and we only see one variable, so we're just going to solve for x. We want to find for what value of x is going to make this left-hand quantity equal our right quantity, equal 15. So we notice the very first thing we need to do is we need to distribute. I mean, just like PEMDAS for our order of operations, the same follows for our equations. The very first thing we need to do is deal with this multiplication. So the first thing we need to do is distribute. Okay, and we know how to distribute. We have 3 of the group 2x plus 7, so we're going to do 3 times 2x and get 6x, and 3 times 7 and get 21. So we have 6x plus 21 equals 15. And now this just turned into a very simple equation that we do know how to solve. So I notice I have 21 positive units on the left, I have 15 positive units on the right, so I know I could subtract 15 from both sides. Okay, I could take 15 units away from the left and I could take 15 units away from the right. So I'm still at my 6x tiles. Well, 21 take away 15 leaves me with 6. So I have 6x plus 6 equals, well, 15. I took them all away, so I'm left with nothing. Okay, now I want to get my x term by itself. That's what solving an equation is. We want to get this x term, our variable term, by itself. So I think, what do I need to get rid of my positive 6? Well, I need to add a negative 6, or I need to subtract 6. Both do the same thing. So I'm going to add negative 6 to both sides. Okay, the negative 6 and the positive 6 cancel out. It's why I do it. So I get 6x equals, now I have nothing, but I added on a negative 6. So I have 6x equals -6. And our last step is to divide our -6 units evenly between our 6x's. So I'm going to divide by 6. Okay, I'm dividing everything by 6. And I get x equals -6 divided by 6 is -1. Okay, and we want to make sure we did it right, so we're going to check our work. So we found out, so we hope that when x equals -1, this left expression is going to equal our right expression. This left expression is going to equal 15. So let's find out, see if we did it right. So I'm going to substitute -1 in for x, because when x is -1, if I do 2 times -1 plus 7, and then I multiply this result by 3, I hope I better get 15. So we could just type this in exactly as we see it on our calculators. So 2 times -1 is -2, plus 7 is 5, times 3 is 15. That's exactly what we wanted. So we're happy, just like we were before when we found out that these numbers are the same. So when x equals -1, both our left and right expression equal 15. So we know we did it correct. That's our whole goal. Okay, so your turn. So press pause after you see this example. Be sure to check your answer before you press play again to check it with me. Okay, so we notice we have an equation we want to solve to figure out for what value of x is going to make this true. So I notice the very first thing we need to do is distribute. 4 times 7 is 28. 4 times x is 4x. This equals 40. I notice I can subtract 28 from both sides. So 28 take away 28 is gone, leaving my 4x. 40 minus 28 is 12. So now I want to divide my 12 units between my 4x's, so I divide both sides by 4, and I get x equals 3. I divide my units by my x's. I'm dividing everything by 4, so I don't know what each y equals. So that's why I divide by 4, because I have 4 of them. Now we're going to check our work. So we're saying when x equals 3, this left expression, if I do 4 times 7 plus 3, I better get my right expression, which is 40. I'm substituting 3 in for my x. Okay, I know 7 plus 3 is 10. 4 times 10 is 40. And that's exactly what I wanted it to be, so we're very happy. So when x equals 3, both my left and right expression equal 40, so I know we did it right. Okay, now let's look at another type of example. Again, we just want to see all types of problems so we build our confidence and get a better understanding of how we could put all of our skills together to solve different types of equations. So let's say we have this equation, 4 times the quantity x minus 3 equals 2 times the quantity 3x plus 1. Now earlier on in the year, if we saw this equation, we might have been afraid because we didn't know what to do, but now we understand, we know how to distribute. Okay, we're comfortable with all our solving equation skills. So seeing an equation like this shouldn't intimidate us. So let's do 4 times x is 4x. 4 times minus 3 is minus 12, because we're good at distributing at this point. 2 times 3x is 6x, and 2 times 1 is 2. So the very first thing we do is we distribute. Okay, now this turns into an equation that we have seen a lot so far, that we are comfortable solving. I notice I have a positive 4x on the left and a positive 6x on the right, so I can subtract 4x from both sides. So 4x, take away my 4x, they're all gone, so I'm left with negative 12. 6x, take away 4x, is 2x, and I still have this plus 2. Again, our whole goal is to get our variable by itself. So I want to get rid of this plus 2, so I'm going to add on a negative 2 or subtract 2. Both do the same things, whatever it's easier to think of for you. So I'm going to say I'm going to add negative 2 to both sides, because I know if I add on negative 2 units, it's going to cancel out with these positive 2 units. So I'm going to add negative 2 to both sides. So I have negative 12. I added on a negative 2. That gives me a total negative 14 equals 2x, because I know these canceled out. That's why we did it. So now we're just going to divide both sides by 2. Okay, we have negative 14 units divided between our two x's, because we want to know what each x equals. So we get x equals negative 7. We're going to check our answers. So we say 4 times negative 7 minus 3. We hope that's the same as 2 times 3 times negative 7 plus 1. So we're just substituting negative 7 in for all of our x's, because we hope when x equals negative 7, our left expression and our right expression will be equal to each other. If they are, then we did it right. If they're not, then we just got to start over and try again. So negative 7 minus 3 is negative 10, times 4 is negative 40. Again, you could just type this into your calculator to get our result. Same thing on the right side. Just type it into your calculator and see what you get. 3 times negative 7 is negative 21, plus 1 is negative 20, times 2. It's negative 40, which is exactly what we want. When x equals negative 7, both our left and right expression equal negative 40. That makes us very happy, because x equals negative 7 is the answer, and we know we did it right. Okay, so your turn again. So why don't you try this example. Be sure to check your work just like we did a moment ago. Then press play when you're ready to check it with me. So we have 2 times the group, or 2 times the quantity 8 minus x equals 3 times the quantity 10 plus 4x. Okay, so we notice there's multiplication to do. We have to distribute first before we do anything else. Okay, so if you notice there's distribution to do, you better do it first, just like the order of operations. So we do 2 times the group. So 2 times 8 is 16. 2 times minus x is minus 2x. 3 times 10 is 30. And 3 times 4x is 12x. Okay, next I notice I have positive 16 units on the left. I have a positive 30 units on the right. So I can subtract 16 from both sides. So 16 take away 16 is gone, leaving only my negative 2x's. 30 take away 16 leaves me with 14 plus 12x. Okay, now I want to get all my x's together away from my units. So my units are all on the right side. So I think, what do I need to get rid of? My positive 12x. Well, I need a negative 12x. So again, you can either subtract 12x from both sides or add on negative 12x. I like the thinking of adding on negative 12x. Okay, so negative 2 plus another negative 12x gives me negative 14x equals 14. And the negative 12x we added on zeroed out with the positive 12x we had. It's why we did it. So now we want to divide our 14 units between our negative 14x's. So we divide by negative 14. So we want to know what does each x equal. So we divide by negative 14, and we get x equals negative 1. Check our work. So we have 2 times 8 minus negative 1. We want to know, does this equal 3 times the quantity 10 plus 4 times negative 1. 8 minus negative 1 is positive 9, times 2 is 18. 4 times negative 1 is negative 4. 10 plus negative 4 is 6, times 3 is positive 18. This makes us happy, because when x equals negative 1, both the left and right expression equal positive 18. So we know we did it right. All right, and one more type of example. Again, we just want to build our confidence. That's why we do so many examples. So we have 4 minus 2 times the quantity 5x minus 4, and that equals negative 6x. Okay, again, there's nothing in this equation that we haven't seen before. We know how to distribute. So the very first thing we do is we want to distribute. Now we have to be very careful here with what we distribute and where we distribute it. All we're doing is we're distributing this, okay? We're doing negative 2 times our group. We have negative 2 of this group. So we're going to distribute negative 2 to our quantity 5x minus 4. So negative 2 times 5x is negative 10x. Negative 2 times negative 4. We have to be careful. We're doing negative 2 times negative 4, which is positive 8. Now we still have this 4 that was out in front. So we have 4 minus 10x plus 8, because we distribute negative 2 times 5x was negative 10x, and negative 2 times negative 4 is positive 8. And this still equals negative 6. Our first step again was to do our distribution. Now I notice on my left side, I have like terms to combine. I have 4 units, I have negative 10x's, and I have another positive 8 units. So I have a total 12 units, my negative 10x's, so we have 12 minus 10x equals negative 6x. And we combine like terms. Okay, I notice I have negative 10x on the left, I have negative 6x on the right, so I can subtract off negative 6x from both sides. I have 10 red x's on the left, 6 red x's on the right, so I know I could subtract 6 of them off, so I can subtract negative 6 x from both sides. 12, and I had negative 10x, I took away negative 6 of them, or I took away 6 of them, and I'm left with minus 4x. Negative 6x, I took them all away, so I'm left with nothing. Okay, now I want to get my x's by himself. Okay, there's 2 options here. I notice I just want to get my x's over here, so I'm going to add 4x to both sides. Okay, because I need a 4x to get rid of my negative 4x, so my 12 is going to stay on the left. The positive 4x is going to cancel out with my negative 4x. They're going to zero out. And I have nothing, and I'm adding on a 4x, so obviously I would have 4x on the right. Now I'm going to divide by 4. I get x equals 3. I'm dividing my 12 units between my 4x's, and I get x equals 3. And I know it takes a little bit of time, but we're going to check our work, because it's better to take extra time and get it right than to get it wrong very quickly. So my left expression, we have 4 minus 2 times 5 times 3 minus 4. We just substitute 3 in for x, and we hope this equals our right expression, negative 6 times 3. So we just plug this into our calculator, see what we get. 5 times 3 is 15, minus 4 is 11, 2 times 11 is 22, 4 minus 22 is negative 18, negative 6 times 3 is negative 18, which is fantastic. When x equals 3, both our left and right expression equal negative 18, so we know we did it right. Okay, why don't you try this one on your own before we end. So we have 2 times the quantity 3x plus 11 minus 4x equals negative 8. So press pause, try this one, and press play when you're ready to check your work. Okay, so again, we notice we have a whole lot of stuff going on, but the very first thing we always need to do is distribute. So if we can distribute, we got to do that first. So we have 2 times the quantity 3x plus 11, so we do 2 times 3x and get 6x, 2 times 11 and we get 22, which is easy because we're good at the distributive property at this point. We still have the minus 4x, and this equals negative 8, because we're just doing 2 times this group, so nothing else really matters when we distribute, and we just make sure we include everything else. Now we want to combine our like terms if we have any. I see we have 6 positive x's on the left, and we also have negative 4x's, so 6x minus 4x is just obviously 2x, plus 22 equals negative 8. We combined our like terms. Okay, I have a positive 22 units with my x's. I think, what do I need to get rid of my positive 22? Well, I need a negative 22. So I'm going to add on negative 22 to both sides to cancel out or zero out with my positive 22. So I have 2x, adding on zeros them out. So I have a negative 8 on the right. I added on negative 22 more. So that gives me a negative 30 total. I divide by 2. We get x equals negative 15. We're dividing our negative 30 units between our two x's. We want to know what each x equals. We get x equals negative 15. We're going to check our work. 2 times 3 times negative 15 plus 11 minus 4 times negative 15. And we hope this equals negative 8. Okay, so 3 times negative, we can just type this all into our calculator. 3 times negative 15 is negative 45. Negative 45 plus 11 is negative 34. Negative 34 times 2 is negative 78. And then 4 times negative 15 is negative 60. Negative 78 minus negative 60 is negative 8. Which is what we want it to be. So when x equals negative 15, both the left and right expression equal negative 8, so we know we did it correct. Okay, again, we're just doing a whole bunch of examples to build our confidence with solving equations, so we're ready for every type of example we see. But we know that solving equations mean the same thing. We want to get that variable by itself to either see, if we have one variable, to see what makes the left expression equal the right expression. So no matter what type of an equation we see, our whole goal is the same thing. Okay, so if you need more examples still, refer back to the textbook or some of the other online resources.